design team consisting of Brett Curley, Caleb Boswell, Riley Fitzpatrick, Mara Sanchez, and Michaela Ellsworth-Reed was tasked by Green Tech Systems Incorporated with designing a hydro turbine to be installed in a Murray River mill dam to utilize a low head of 3.5 meters to produce a maximum of 30 kilowatts. To do so, a MATLAB code was developed using equations for NACA 4412 airfoils to calculate optimized profiles for the turbine blade angles of attack. These profiles were then exported to SOLIDWORKS and extruded to define the blade. A hub was then designed with blades evenly spaced around its perimeter to form a turbine. A D-shaped die cut was implemented to secure the turbine to the shaft. Scaled versions of the turbine model were then 3D printed using resin with varying numbers of blades for testing. The turbine model is secured to a shaft, which is connected via flex coupler to the generator before being attached inside the 3-inch diameter piping. Due to the insufficient flow pressure inside the pipe at this diameter, a shroud was designed complete with a support structure for the shaft to ensure that the turbine was entirely submerged during testing. 3 sets of tests were conducted for each turbine blade configuration, both for a horizontal axis as well as a vertical axis setup. In each test, data of the voltage output, the RPM, and the flow rate were collected to analyze which number of blades performed the best. The testing confirmed that the 7-blade configuration produced the most desirable results, with a higher power output as compared to the 6, 5, and 4 blades. As such, the recommended design for the implementation on site is a 7-blade turbine with a 50 centimeter diameter.
It is recommended that the implementation be manufactured using SLS 3D printing as opposed to SLA for its increased durability. Initially, we were tasked with creating a horizontal axis turbine, and this will be our final design selection. However, we strongly recommend a vertical axis turbine if the client is seeking a higher energy yield.